All right, in section 5.3, we're going to start looking at some of our right triangle trigonometry and our trigonometric ratios. So all trigonometry really is it is a relationship between the sides of a right triangle. And then it has, of course, lots of extensions. So if I take any two sides of a right triangle and I divide those to get a ratio, that is a trig ratio. And the different sides give you different ratios. So to make life easier, we typically will give names to these sides of a right triangle based on some angle. The first one is a hypotenuse. The hypotenuse is always the side across from the 90-degree angle. Since we're all talking about right triangles, there's always going to be a side across from a 90 because there's always going to be a 90. And it's always the longest side. So if we look at our triangle up here, this would be the hypotenuse because it's across from this 90-degree angle in this triangle. Now the opposite and adjacent sides actually depend, and they are actually dependent on what angle you're using. So if I take this angle here, this angle B, then the opposite side would be the side across from it. So the opposite side is just the side across from an acute angle. The other two angles in the triangle are always acute, less than 90, because triangles, if you recall from geometry, always add to 180. The last side is the adjacent side. And adjacent side is essentially just means next to. So it's essentially next to one of our acute angles. So in this triangle, this would be the adjacent side to angle B. Again, it's very important that it's from a certain angle. So the adjacent side is the side across, next to an acute angle. Now there are technically two sides next to this acute angle. There are two sides that make up the angle, but one side will always be the hypotenuse, so that's not going to be our adjacent side, it's going to be the other side. Now, like I mentioned, what we know is if I take any two of these sides and divide them, we get a ratio. So the idea behind trigonometry is if I have a couple different triangles, let's say I have two triangles that are different sizes but have the same angles. So we'll call these right angles. We'll say these are the same, and we'll say these are the same. Well, these are now similar triangles, as you know from geometry. So if we take any two sides and divide them, so if I take this side divided by this side in the little triangle, and I take the same two sides in the bigger triangle that have the same angles, the ratio of those two sides will be the same. And so we just call those trig ratios. So we define 6 trig ratios for every right triangle. We have the sine, cosine, and tangent, which are the typical ones we see. And then we have cosecant, secant, and cotangent. So if we look at this triangle here, we have an angle in the corner here, and this is this is done a lot in trig, where you have this angle theta. Theta is just a Greek symbol, and so we usually use that to represent the angle. So if we see this in a problem, that helps us define what's our opposite and what's our adjacent. So this is AB is the hypotenuse. This is definitely the hypotenuse. It's across from the 90. And then across from this given angle theta is this side AC, so that becomes the opposite. And then the other leftover side, the side next to the angle, is the adjacent. So you can see as you go through these different ratios have different names. So the sine is just the opposite side divided by the hypotenuse in any triangle that has an angle theta. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. A lot of times they have the abbreviation SOHCAHTOA. If you've ever heard that, SOHCAHTOA, sine is the opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. Tangent is the opposite over the adjacent. Now our last three are cosecant, secant, and cotangent. They are less well known but very important. And essentially they are what we call reciprocal identities, or reciprocal ratios, because if you look, cosecant is the same as sine, it's just flipped over. So sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. Same thing for cosine and secant. Cosine and secant. Cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And finally, we have tangent and cotangent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. So in any triangle with a given angle, the ratios of the sides are always the same. So no matter how big or how small the triangle is in ratio, the sides are always going to be the same in ratio. So some problems we can do where you're given a triangle and you can find these ratios. That's the big kind of problem we're going to deal with in this first section. So if you see a triangle like this with all the sides given, we can actually find what is the sine, cosine, tangent, cosecant, secant, cotangent of this triangle. So first thing to notice is we have angle theta, so all these problems are looking for the trig ratios of angle theta, because you see the theta is the angle you have here. So that helps us help our hypotenuse. Hypotenuse is always across from the 90, that's not going to change. So 10 is the opposite, because again it's across from theta, and so then 24 becomes the adjacent. So now I'll just divide these sides to get my ratio. Sine is opposite over hypotenuse, so that's 10 over 26. 10 over 26 reduces to 5 over 13. So what that means is if I have any triangle that has the angle theta, let's say I draw a really big triangle here, not to scale. So let's say I have an angle theta here. So if I take the opposite side, whatever length that is, and divide it by the hypotenuse, so we can call this, I don't know, we'll call it x and y. If I divide x over y, I should get 5 over 13. And the key thing is they both have the same angle theta, so all their angles are the same. Cosine is adjacent over hypotenuse, so now we're just using SOHCAHTOA, so that's 24 over 26, which reduces to 12/13. And tangent is going to be opposite over adjacent, which is 10 over 24, which is 5 over 12. Now for the last three, I've kind of made it really easy because I put them across from their reciprocal relationship. So cosecant is the flip of sine and secant is the flip of cosine and so on and so forth. But it is important to start to commit those to memory. So cosecant is the flip of sine, so 13 over 5. No need to do it for the first one, might as well do it for the one that's reduced. Secant is going to be 13 over 12. And cotangent is going to be 12 over 5. So let's look at one more problem that kind of finds these ratios. Now this one is pretty similar. The only difference in this problem is we are missing one of the sides. So in this one we're missing this side over here, so I'll call it x. Now the nice thing is we can still find this side because we know that all sides of right triangles are related by the Pythagorean theorem. So this one over here is the hypotenuse. So we're looking at angle A this time because they all say A. So the opposite side is going to be the 50. So this unknown side is the adjacent. So first let's go ahead. We can't want to leave it just x. We actually want to find this side. So we can use the Pythagorean theorem. X squared plus 50 squared equals 60 squared. Because remember, in Pythagorean theorem, it's always the square of the two legs added together equals the square of the hypotenuse. So that hypotenuse always has to be by itself. So if you think a squared plus b squared equals c squared, c is the hypotenuse. So let's evaluate this. So we have x squared plus 2,500 equals 3,600. I'll subtract 2,500 from both sides and get 1,100. I'll take the square root. So the square root of 1,100 is the square root of 100 times the square root of 11. So it is 10 square root 11. So now we know this other side, this x, is 10 square root 11. Very important not to put the decimal. We want to keep these exact. Exact ratios are very important, so we want to make sure we keep the exact value. So 10 radical 11, not whatever its decimal equivalent would be. So now it's really quite simple. It's just like above. Sine is going to be opposite over hypotenuse. So that's 50 over 60, which reduces to 5/6. Then I can do the cosecant, which is 6/5. So 5/6 for sine, and 6/5 for cosecant. Cosine is going to be adjacent over hypotenuse. So that's going to be 10 radical 11 over 60. So that's going to be radical 11 over 6. So when I take the reciprocal, I get 6 over radical 11, which is okay, but we typically don't want radicals in our denominator, so I'll rationalize that by multiplying top and bottom by radical 11. So that gives me 6 radical 11. Radical 11 times radical 11 is 11. Tangent is opposite over adjacent, so that's going to be 10 over, pardon me, it's going to be 50 over 10 radical 11, which is 5 over radical 11. Same rationalization will give me 5 radical 11 over 11. And if I flip it, I'm just going to flip it from here. I can flip it from any spot I want, but it's easiest just to flip it from here and go radical 11 over 5. So again, any triangle with these same angles, A, B, or A and C and the 90, would have these ratios of their given sides. So one other problem we could be given is something like this, where it says if the cosine of A equals 3 over 4, find the other 5 trigonometric ratios. Now right now this is an oversimplified problem. These problems actually do get a little trickier when we actually can think about angles that are bigger than 90 or bigger than 180 or negative angles and things we talked about, different types of angles in section 1. But for now, we can look at how we can find ratios when we're just given one. Well, what I'm going to do first is I'm going to draw a triangle. And I'm going to draw it to be a right triangle. And I'm going to put angle A here. Well, what I know about this triangle is I know the cosine of A is equal to 3 over 4. Well, 3 over 4 right now, we know cosine is the adjacent side divided by the hypotenuse. So I actually know 2 sides in this triangle. The hypotenuse is 4, and the hypotenuse is always the side across from the 90, so 4 goes here. So the adjacent side we know is going to be down here, so that's going to be 3. So this is hypotenuse, and this is adjacent to angle A, and I could have put A in the corner, but I didn't. So this would be the opposite side. And we don't know that, so we'll call it, I don't know, Y. So now I can find Y, so Y squared plus 3 squared equals 4 squared. So Y squared plus 9 equals 16. Y squared equals 7. So Y equals square root of 7. Now don't forget that this could be the plus and minus, but right now we're just going to keep it positive, but in the future that plus and minus could be important. So now let's go ahead and find our ratios. We want the sine of theta, cosine of theta, tangent of theta, cosecant theta, secant theta, cotangent theta. And then we'll just take the sides we know and we'll plug them in. Remember, we had y is radical 7. So sine is opposite over hypotenuse, so that's radical 7 over 4. Cosecant would be the reciprocal of that, 4 radical 7, which is 4 radical 7 over 7. Cosine is adjacent over hypotenuse. That was already given. It was 3/4. Secant is 4/3, another easy one. Tangent's opposite over adjacent, so that's radical 7 over 3. And so if I flip it, I get 3 over radical 7. Rationalizing that, I get 3 radical 7 over 7. So again, just real quick to get you your ratios of right triangles. And these ratios will be very important as we go forward. We'll actually look at solving some triangles that aren't necessarily right, trying to find all the angles and sides of these triangles to finish up this chapter.